for short, is the Voljet SX-255, which was developed and test-flown in California in 1982. The SX-255 was an experimentally licensed proof-of-concept prototype, which led to the present development of the Voljet 585, a 5-place, single-turbine civil helicopter, the building of which is scheduled to begin in 1986. The SX-255 was preceded by 2 other prototypes successfully built and flown by founders of Voljet International, and was the result of several years of design, development, and testing of APJ helicopters. The fundamental difference between an APJ helicopter and other helicopters is the APJ's elimination of the undesirable effects of torque. The most obvious result of the torqueless drive system is, as can be easily seen here, the elimination of the long tail boom and the tail rotor it supports. As we'll see later, this is only one of many significant advantages that APJ helicopters have over their shaft-driven counterparts. The helicopter uses an engine to turn its rotor with a drive shaft through a transmission, much the same as a car has its driving wheels turned on their axles. This mechanical linkage between the engine and the rotor creates a force known as torque, which tends to rotate the fuselage in the direction opposite that of the rotor. A tail rotor is most commonly used to counteract this force in order to maintain the aircraft's stability and to provide directional control. The APJ helicopter simply uses its engine to drive an air compressor, which forces compressed air through a hollow rotor system and out the rear of the tips of the rotor blades. Because the rotor is turned from the blade tips rather than from a central drive shaft, the unwanted effect of torque is eliminated, and with it, the need for a tail rotor. Directional control is maintained simply by deflecting the engine exhaust stream with a vertically mounted. The air pressure jet concept is not a new idea. Earlier developmental efforts, however, were limited by the state-of-the-art of supporting technology, proceeded along a path of shaft-driven propulsion systems. Unfortunately for the helicopter operator and for the public, the industry has proven to be resistant to innovation, in much the same way that the American automobile industry was resistant to small, practical automobiles. But times and technologies have changed. Dramatic improvements have been made in engine and compressor efficiencies. Space-age materials are available today which substantially reduce aircraft weight and provide much more effective sealing of the air ducting system. Voljet International has utilized these technological advances to successfully develop and fly 3 prototypes over the last several years. The first APJ prototype was the H-100, built and flown in Arizona in 1972 as an initial step in evaluating advanced air pressure jet concepts. The flight test program emphasized development of the rotor system and analysis of the APJ's stability and performance. Established by the H-100, with an emphasis on flight characteristics at higher speeds and increased payloads. The third prototype, the SX-255, was built and flown in California in 1982. It represented major improvements over the H-100 and H-200 in rotor and propulsion systems, as well as in overall performance. J has many significant advantages over shaft-driven helicopters. One of these advantages, mechanical simplicity, is best illustrated by comparing the drive components of the 2 systems. A typical shaft-driven helicopter has an engine, a primary reduction gearbox, a connecting drive shaft, a complex transmission with a disengage device, main rotor reduction gears and takeoff, tail rotor reduction gears and takeoff, main rotor drive shaft, main rotor hub, tail rotor drive shaft with support bearings, tail rotor gearbox, and a tail rotor. By comparison, the APJ helicopter simply has an engine, a compressor forcing air through a flexible hose, and a hollow hub and rotor system. Engine exhaust is ducted back to the rudder for directional control. This mechanical simplicity has tremendous significance. It means less maintenance, simpler maintenance, reduced spare parts requirements, and greater availability and reliability than for its shaft-driven competitor. The results are real dependability and real dollar savings. A second advantage of the APJ is that it is easy to fly. The freewheeling, high-inertia rotor system is free from the unstable cross-coupling that occurs with the use of controls in shaft-driven helicopters. The inherently gyroscopic rotor passes no stresses through the rotor hub or airframe and produces surprisingly little vibration. To demonstrate this stability, the pilot hovers the H-100 with both hands off the controls. The helicopter moves only in reaction to the change in center of gravity caused by the pilot's movements, or, of course, if pushed by the wind. This remarkable stability also exists in forward flight, as shown here by the H-200. If you watch closely, you can see the pilot's hands outside the window as he cruises by, demonstrating the same stability in forward flight that we saw in the hover. Here is another view of the SX-255, performing maneuvers near the ground. Notice the smooth, steady, vibration-free hover. This torqueless, gyroscopic stability makes the air pressure jet truly easy to fly. It is less demanding of pilot skills and reaction time, resulting in shorter or more productive training time, and in a greater number of successful pilot candidates. Its inherent stability, coupled with its high inertia rotor system, also gives the APJ helicopter the benefit of increased VTOL, that's vertical takeoff and landing, performance. The rotor operates safely across a wide range of RPM without requiring power changes. Thus, most maneuvers are accomplished with little, if any, worry about loss of rotor RPM. A unique maneuver, the dynamic climb, is one dramatic result. The APJ's rotor is sped up to its maximum RPM prior to takeoff, and the helicopter then leaps into the air at the pilot's demand. This technique is fully practical for overweight and obstacle clearing requirements. Next, we see a dynamic climb from the hover, followed by a rapid descent and immediate entry into another dynamic climb. This benefit can also be exploited in landing when altitude over shaft-driven helicopters is in the APJ's reduced noise level. This is particularly important in urban areas where noise is a major problem for shaft-driven helicopters, and for uses where it is desirable for the helicopter to remain undetected, as in certain police operations. Notice that the relatively low noise generated by the SX-255 does not include the blade slapping sound so commonly associated with most shaft-driven helicopters, nor, of course, is there any tail rotor or transmission noise APJ has over its shaft-driven competitors. But probably the most important advantage is in the air pressure jet's greater safety. As already seen, the elimination of the instability related to torque significantly reduces the degree of pilot skill and attention required to safely fly a helicopter, thus reducing accidents attributed to pilot error. North American statistics covering 70% of the world's civil helicopters reflect that over 40% of their accidents result, in one way or another, from use of the shaft-driven system. The majority, if not all of these, would be eliminated with the APJ. For example, the lack of a tail rotor precludes all accidents associated with it, resulting in a significant improvement to both in-flight and ground safety. In an engine failure situation, the APJ helicopter has tremendous advantages over shaft-driven helicopters. Firstly, there is no need to rely upon a complex device to disengage the rotor from the transmission, since the APJ rotor always rotates freely. Following engine-out maneuver by the SX-255 illustrates this. The passenger, to your right, signifies that the pilot has cut the engine with a quick wave of his arm. There. The helicopter maintains its hover for 4 seconds before it starts a smooth descent to a safe landing. In other flights, the SX-255 has maintained its hover for up to 8 seconds before descending, following engine stoppage. This means that the list of advantages of the air pressure jet helicopter over shaft-driven helicopters is an impressive one, particularly as its sole disadvantage of higher fuel gauges, and more are incorporated into the design of the Voljet 585 five-place civil helicopter. The delivery of the Voljet 585 to the world helicopter marketplace will be a major step forward